Hello, dear friends. Today we learn to analyze the beam and draw the bending moment and shear force diagram. Now this beam is a fixed beam. Now already we have learned the standard cases for this eccentric load, also the partial UDL. Now if suppose draw the diagram separately for this, suppose we consider this is a separate diagram like this. Here like this, suppose this is the UDL, and again draw the diagram, and suppose consider this point load separately. Suppose this, now this is load is 100 and suppose this is 30 kilonewton per meter. This is a 4 meter. Now this distance becomes 6 meter, 4 plus 2, and this becomes 2 meter. Now here we want this total, the MA here and MB here. Okay. So now MA is nothing but first is due to a partial UDL plus the due to point load. Okay, so here due to this partial UDL we know the fixed end moments directions are like this here, and here is direction is like this. So this both the diagrams, both moments are the hogging. Suppose this is our MA1 here and this is MB1. Now for and due to this point load we know here a moment develops are like this. So this we called as MA2 and this we called as MB2. Now, due to partial UDL, we know the formula, that is what? Integration this 0 to a w into dx into x into L minus bracket square divided by L square. Now, because of this hogging bending moment, we consider this sign as negative. For this point load, the fixed end moments are also the hogging, that is why is minus. The formula is W A B square by L square. So now here 0 to A means starting point is 0. Starting point is here is 0. So minus integration 0. Now end point is the 4. So is the 4. Now W is how much is 30. So 30 into x into L is how much is 4 plus 2, 6 plus 2, 8. So 8 minus x bracket square divided by 8 square into dx minus. For this W is how much is 100, A is 6 and B is 2 meter. So this become 2 square divided by 8 square. Now if we integrate this 0 to 4, this value is the minus 110 and this value is minus 37.5. so this becomes total minus 147.5 kilonewton meter. This minus sign indicates that this total moment is the hogging moment. Now the MB is again what? Is due to UDL and due to the point load. Same line of action here. Now due to this UDL, MB is equal to what here? Formula is minus again 0 to A W into dx, here x square into L minus x. What is the formula? Is W first time is WAB square by L square, and second time is WA square B by L square, like this. Minus here, due to this point load here, the moment is WA square B by L square. So here minus, again the starting point of the UDL is here, starting is the 0, so 0, ending is the 4, W is the 30, now x square into 8 minus x is divided by L square, so divided by 8 square into dx minus this 100 into 6 square into 2 divided by 8 square. So this total becomes, here is minus 50 and this becomes minus 112.5, so this becomes total is minus 162.5. Okay, we got the fixed end movements now. Now our aim is to draw the BMD and the SFD. Now for the BMD we have to draw the first free BMD. For the free BMD again we require the reactions. So free BMD means removing the fixed end moments. So consider this beam is like this, simply supported. Free BMD means consider the beam is simply supported like this. This is the only loads on the beam. This is called as a simply supported beam. This is used for the free BMD. So this is 30 kN per meter. Now if you find the reaction for this is, if 30 multiplied by this is 4, 2 and this is 2. Now here if you find the reactions, this point is A, this point is B, so sigma MA is equal to 0, so 30 into 4, okay, 30 into 4, this becomes the load. Now multiply by the central distance up to the point, so 4 divided by 2, that is becomes 2. This moment is a clockwise, that is why plus. Now here 80 into the distance is 6, so again this is what, clockwise, so plus 80 into 6. Now we are assuming direction of RB is vertical, we are assuming, so that is anti-clockwise, so that is minus 8 RB, and that is equal to 0. So here this RB becomes the 105. Then apply sigma Fy condition here. So we got this RA plus RB minus 30 into 4 and minus 80 is equal to 0. So RA plus 105 minus 120 minus 80, so that is equal to 0. So this becomes RA is equal to it becomes 115 kilonewton. Okay, so we got the value of RA here is 115 for simply supported beam, and here got the value is 105. Now here is a UDL. Okay, so here we have to draw a simply supported beam shear flow diagram, so that we'll get the contrast shear. So first, before the bending movement, we'll draw here the shear flow diagram. Now from the right side upward force is negative, so this becomes is here 105. Up to this is a straight. Now here this is not 80, this is the 100. Okay, so this is not, this 80 is not here, it is 100. So okay, so here is 100. Sorry for mistake here. Okay, this answer is the correct here. Okay, so because of 100, so it becomes here the 100 up to here. Now up to here, this is the constant. Now from the left side, upward force is positive, so this is 115 here. Now join this. This is the 5, this is minus, and this is the plus. So again we got this point is a contrast here. So if we find distance, suppose this is x and this is the 4 minus x. So x divided by 115 is equal to 4 minus x divided by the 5. So this x becomes 3.83 meter. Okay, so again we got one point where the bending moment is the maximum, where shear force is the 0. Now the bending moment. So now we know the bending moment at A and B is equal to 0 because of simply supported. Okay, so now again bending moment at this point. Suppose bending moment at, suppose this is A, B, this point is C, this point is the D, and this contrast shear point is, suppose, is the E. So bending moment at C is equal to what? At C is equal to what? 105 into 2, and this upward force create the sagging. So this try to push this beam legs upward. So this is a plus 105 into 2. So this becomes 210. Then bending moment at the D. Here what? From the left side 115, this create the sagging bending moment. So 115 into 4 minus 30 into 4 into 2. So this becomes the 220 kilonewton. If we do here the calculations, 5 into 4 minus 30 into 4 into 2. Okay, 220. Now the last is the what? Bending moment at the, or bending moment maximum, BM maximum is equal to, at this point, at here, that point is 3.83 meter. So 115 into 3.83 minus 30 into 3.83 into 3.83 divided by 2, so that square by 2. So this calculation becomes 220.41. Okay, now here from these 4 points we got the simply support free BMD. We got the free BMD. That beam is considered as simply supported. We got the free BMD. So now here, the bending moment diagram here now. Now suppose this is our beam. Here is the UDL. This is the point load 100. This is 30. This is 2. This is 2. We know that moment is Hawking bending moment. Here is how much is 147.5 and here is 162.5. Both are in Hawking nature, 162.5. So now first we draw the simply supported. So drop this point at here. And one is a contrast shear. This point is 3.83. So like this, okay, and from here this then is how much is here. Bend moment at C is 210, like this. From here this is 220, this is 220.41. So this is the free BMD diagram. Now here we have to superimpose the fixed BMD. Now this fixed moment is this A support and at support B. Now this moment is create the Hawking bend moment. So that is the minus. This diagram is this is a plus. Total diagram is a plus. Now here superimpose 147. So here is somewhere here is 147.5, but that is negative. Here is a 162 is somewhere here. So join this. So this diagram is the negative diagram. So I like this. Okay. So this diagram is negative here. This diagram negative. This negative positive get the cancel out from here, and remaining is the plus. So this is the combined BMD diagram. Now the final shear force diagram. For final shear force diagram, again we have to find out the shear force reactions. For this, considering the external movement, these fixed end moments, considering this fixed end moment, again find the reactions. Now next step is the SFT. Again take here the sigma MA is equal to 0. Sigma MA is equal to 0. This moment again is a plus. How much is 30 into 4 into 2 plus 100 into 6. Now this moment is clockwise, so plus 162.5, and this is anti-clockwise, so minus 147.5 is equal to 0. So here not 0, and then again minus this RB into 8 is equal to 0. So this RB becomes here 106.87. Okay. Again, if you apply here sigma Fy condition equal to 0, then again Ra upward plus, here by assuming that upward is plus, downward is minus. Here clockwise plus and anti-clockwise minus. That is why this is a plus and this is minus. In case of the moments, consider clockwise positive and anti-clockwise negative. And in case of bending moment, sagging is positive and Hawking is the negative. So Ra plus Rb minus this 30 into 4. 30 into 4 is a force. Then minus 100 is equal to 0. So Ra plus 106.87 minus 120 minus 100 is equal to 0. So this Ra becomes 113.13 kilonewton. So these are the reaction considering the fixed end moment. Considering the fixed end moment. And the previous one, this. this shear force diagram was only for the considering simply supported beam. Okay, so now this is the final BMD. So again we have to draw the final shear force diagram. For that, again here, so now we got here the reactions. RA is equal to how much is 113.13 and this RB is 106.87. So we know again from the upward side, if you consider shear force at here, so from right side upward force is negative, so that is minus, okay, 106.87. Now this shear force is constant up to here. So if we now if you find the shear force at here, how much is the negative 106 plus 100, that is minus 6.87. So here is again 6.87 at here. Now this is from here to here is a constant. So up to here, this shear force is constant here. Then shear force at this RHS of A, we know always the from left side upward is the positive, so that is 113.13. Now join this. Okay, so above the line is plus, below the line is minus. So this is the final SFT and this is the final BM.